This lesson isn't a new technique, but we use our 3 techniques to look at special solutions. If you remember when we did equations, we had equations that had a solution, but we also had equations that had no solution or an infinite amount of solutions. So we're going to look at systems that have that as well. So that's what this is all about. So let's look at how we would do a system that has no solution. So if you notice, the equations are written in slope-intercept form. So I'm going to graph this one. I'll do this in red, and this other one will be in blue. So the red one has a slope of 3 and a y-intercept of 0, 1. So let me make my grid. And now I'm going to put a dot at 0, 1 and go up 3, right 1. I can also go down 3 and left 1. That makes the same line. Get a straight edge, please, to make the line. Make sure you go through the whole grid. All right, and then we're going to switch over to the other one. The second equation has a slope of 3 and a y-intercept of -3. So I'm going to put a dot at -3. I'm going to go up 3, right 1. I have enough space to do that again. And now let's make the line. And what you'll notice is that the lines are parallel. So what makes them parallel, we vaguely talked about this back in chapter 4. They have the same slope. Parallel lines have the same slope. But the reason that they don't ever intersect is because they're rising at the same speed. So this is what it would look like graphically when there's no solution. And again, you have to say the answer. The picture is not the answer. So the answer would be the point of intersection. But since there's no point of intersection, we have to say no solution. You could also have done this using the substitution technique. Let's look at that. So if you take our 2 equations, remember substitution is when you take one expression and you plug it into the other. So if y equals 3x plus 1 and y also equals 3x minus 3, then I can take 3x minus 3 and plug it in for y. Because if they both equal y, then they must equal each other. So I've got, instead of y equals 3x plus 1, I can write 3x minus 3 equals 3x plus 1. And then I will drop a line down. Oops. I'll do variables on the left, which means that this 3x has to move. And then when they actually cancel on both sides, you have -3 equals 1, which is not true. So since we get this thing that isn't true, then we would say also no solution. We did things like this back in lesson 1.3. All right, we've got one other special case, and that's when you have 2 equations and they have an infinite number of solutions, meaning that they intersect everywhere together. So this looks like it's in standard form, and it has friendly integer intercepts. So I will get the grid ready. So again, I'll do that one in red, and then this one will be in blue. So the red one has an x value of 6 and a y value of 3. So x value 6, y value 3. There's the line. And now we go to the other one. This one has an x value of 6 and a y value of 3, so that's actually the same line, right? Like if I were to plot it, it would land right on top of the other one. So all the points on the line are actually considered intersection points. So what we say in this case is infinite number of solutions. You can also solve it using elimination, because if you look up above, you can see that they are in standard form, which was helpful when we graphed. So let's line them up. So I have x plus 2y equals 6. And then the other equation is 3x plus 6y equals 18. So if you want to use elimination technique, you would multiply to make something cancel. So if I want to turn the x's into 3's, I'll multiply this first one by negative 3. So that would give me negative 3x minus 6y equals negative 18. And then when you go to line it up with the other one, you see that not only do the 3's cancel, but everything cancels. That cancels, that cancels, that cancels. So you have 0 equals 0. When you get the same number on both sides, back in chapter 1, we said that you say infinite number of solutions, or infinitely many solutions. All right, before we wrap this up, let's check out this word problem down below. You and your friend plan an urban garden. You paid $25 for 6 tomato plants and 6 pepper plants. Your friend pays $22.50 for 9 tomato plants and 9 pepper plants. And then what we have to do is figure out how much does each plant cost. So they give us the setup guide again. So let's do that. So first one is for you. So I have 6x plus 6y is equal to 25. And then the second equation is going to be my friend. So that's 9x plus 9y is equal to 22.50. So if you want to solve it, you have to make something cancel. So let's turn them both in. Let's turn the x's into 18s, because that's something that 6 and 9 both have in common. So multiply this one by negative 3 and this one by 2. That way the top one will turn into negative 18 and the bottom one will turn into positive 18. So I get negative 18x minus 18y. Got to get my calculator out. No, I don't. Equals negative 75. I know that. And then let's do the other one. 2 times 9, that's 18x plus 18y is equal to 22.50 times 2. That's 45. So now when I go to add, these cancel and also these cancel. So I just have 0 on the left because everything canceled. So I have to put a 0 to keep something on the left side. You can't just leave it empty. And then negative 75 plus 45 is negative 30. Does 0 equal negative 30? It's not a trick question. No, of course it doesn't. So since this doesn't make sense, then there's no solution. Doesn't mean that there's no solution in terms of this word problem. It just means that it's a ridiculous question because you can't figure out the price of the tomato plants and the price of the pepper plants because of the way the equations are written. So either it's not enough information or the store is totally messed up and they're charging you a different price than your friend. Either way, there's not a possible way based on what we know to figure it out. So we say not possible to determine. In equation land, we would say no solution, but since this is a real world problem, we're going to make it more of a real world answer by saying we can't figure it out. If you have any questions, write them down and ask me when you come to class.